For centuries, the star Betelgeuse, a fiery red supergiant in the Orion constellation, has captivated astronomers and stargazers alike. Known as one of the brightest stars in the night sky, its massive size and unpredictable behavior have long hinted at its impending demise. Scientists have speculated for decades that Betelgeuse, located just 642 light-years from Earth, was on the verge of a catastrophic explosion, a supernova. Now, in an unprecedented breakthrough, the James Webb Space Telescope, JWST, has captured the moment humanity has been waiting to witness: the explosive death of Betelgeuse. This is not just a cosmic spectacle. It is a once-in-a-lifetime event, offering a front-row seat to the raw power of the universe and reshaping our understanding of stellar evolution, element formation, and the very origins of life. This article delves into the extraordinary observations made by JWST, the significance of Betelgeuse's supernova, and the profound implications for astronomy and our place in the cosmos. From the star's turbulent history to the intricate details of its collapse, we explore how this event is rewriting the textbooks on stellar death and galactic evolution. Betelgeuse, also known as Alpha Orionis, is no ordinary star. As a red supergiant, it is a behemoth with a diameter more than 700 times that of our Sun and a mass approximately 20 times greater. If placed at the center of our solar system, Betelgeuse would engulf the orbits of Mercury, Venus, Earth, and Mars. Its immense size and mass make it inherently unstable, and for decades, astronomers have observed signs of its impending collapse. Betelgeuse has been swelling, dimming, and erupting in ways that defy simple explanation, earning it a reputation as one of the most enigmatic stars in the sky. In 2019, Betelgeuse underwent a dramatic dimming event, fading to just 35% of its usual brightness. This phenomenon, dubbed the Great Dimming, sparked global speculation. Was this the long-awaited precursor to a supernova? Some hypothesized that the dimming was caused by a massive dust cloud ejected by the star, temporarily blocking its light. Others believed it signaled the final stages of Betelgeuse's life, as its core began to falter under the weight of its own gravity. While the star later regained some of its brightness, the event underscored its volatility and kept astronomers on high alert. Enter the James Webb Space Telescope, launched in December 2021, which has revolutionized our ability to observe the universe. Unlike its predecessor, the Hubble Space Telescope, JWST, is designed to peer into the infrared spectrum, allowing it to see through dust clouds and observe phenomena invisible to optical telescopes. Its advanced instruments, including the near-infrared camera, NIRCam, and the mid-infrared instrument, MIRI, provide unprecedented resolution and sensitivity, making it the perfect tool to study a star like Betelgeuse. For months, JWST has been trained on Betelgeuse, capturing data that reveals the star's inner workings in real time. The telescope's infrared vision has allowed astronomers to penetrate the star's outer layers, observing processes that were previously theoretical. What JWST has revealed is nothing short of astonishing. Betelgeuse is not just dying, it is transforming in a spectacular display of cosmic violence. The data from JWST paints a vivid picture of Betelgeuse's final moments. For the first time, astronomers are witnessing the real-time collapse of a massive star, a process that unfolds over days, weeks, and months rather than millennia. The telescope has captured several key indicators of this cataclysmic event. JWST has observed massive convective bubbles, some as large as Jupiter, erupting on Betelgeuse's surface. These bubbles are caused by the star's turbulent interior, where hot plasma rises and cooler material sinks, creating a chaotic dance of matter. The telescope has detected plumes of superheated gas streaming into space at incredible speeds. These plumes are evidence of the star's outer layers being blown away as its core begins to collapse. Hidden within the light spectrum, JWST has identified a signature shock wave moving through Betelgeuse's outer layers. This shock wave is a hallmark of a supernova, as the star's core collapses and releases a torrent of energy that ripples outward. The data reveals disruptions in Betelgeuse's magnetic fields, with twisting and tangling lines of force that indicate the star is tearing itself apart from within. These observations mark the first time astronomers have witnessed the real-time physics of a supernova. Unlike simulations or distant observations of supernovae in far-off galaxies, JWST's data provides a detailed, up-close view of a star in its death throes, just 642 light-years away. Betelgeuse's proximity to Earth makes this event particularly significant. Most supernovae occur in distant galaxies, millions or billions of light-years away, making detailed observations challenging. Betelgeuse, however, is practically in our cosmic backyard. When its supernova reaches its peak brightness, it could outshine the full moon and be visible during the day, a phenomenon not seen since the supernova of 1054, which created the Crab Nebula. This proximity offers a unique opportunity to study the mechanics of a supernova in unprecedented detail. Astronomers can observe how the star's core collapses, how heavy elements like carbon, oxygen, and iron are forged in the explosion, and how the resulting shock wave reshapes the surrounding interstellar medium. These processes are not just academic. They are fundamental to understanding the origins of life itself. Supernovae are the universe's forges, creating the heavy elements that form planets, oceans, and living organisms. Betelgeuse's explosion is no exception. JWST's data reveals that the supernova is releasing a wealth of elements, including carbon, oxygen, iron, and even rarer elements like technetium and yttrium, which form only in the extreme conditions of a dying star. By analyzing the ratios of these elements, scientists can trace the life cycle of matter in our galaxy, from the cores of stars to the dust clouds that coalesce into planets and, ultimately, to the atoms that make up life on Earth. This discovery is profound. The elements forged in Betelgeuse's supernova are the same ones that formed our planet and our bodies. In a sense, we are witnessing our cosmic ancestry in reverse, a glimpse into the processes that created the building blocks of life billions of years ago. The collapse of Betelgeuse's core may have produced more than just light and elements. Astronomers are now investigating whether the supernova generated gravitational waves, ripples in the fabric of spacetime caused by massive, accelerating objects. The detection of gravitational waves from a supernova would be a groundbreaking achievement, linking visible light observations with the invisible distortions of spacetime. JWST has already detected early ripples in the interstellar medium, as high-energy particles from the supernova heat surrounding gas clouds and alter the structure of Betelgeuse's dust halo. These ripples could have far-reaching effects, potentially influencing nearby star systems and changing how light from other regions reaches Earth. While Betelgeuse's explosion poses no direct threat to our planet, its impact on the galactic neighborhood could reshape our view of the cosmos. As Betelgeuse collapses, one of the greatest questions in astronomy looms. What will remain? The fate of a massive star depends on its mass and the dynamics of its collapse. Betelgeuse could leave behind a neutron star, a dense, city-sized object composed almost entirely of neutrons, or a black hole, an object so massive that not even light can escape its gravity. Intriguingly, JWST's data suggests that Betelgeuse's collapse may not be entirely uniform. The telescope has detected magnetic field disruptions, plasma voids, and signs of asymmetric fallback, where material is drawn back into the star's core rather than being ejected into space. Some astrophysicists speculate that Betelgeuse could form a transitional object, a rare phenomenon that exists between a neutron star and a black hole. Such an object, known as a quark star or strange star, has been theorized but never observed. If confirmed, this would be a landmark discovery, opening a new chapter in our understanding of stellar remnants. The explosion of Betelgeuse is more than a singular event. It is a key to unlocking the hidden processes behind galaxy formation, planetary systems, and the cycle of life in the universe. Through JWST's advanced instruments, astronomers can now model the final stages of stellar evolution with unmatched precision. This data will help refine our understanding of how stars live and die, and it may even allow scientists to predict future supernovae by identifying telltale signs in other massive stars. Moreover, the supernova's shock wave and elemental output will influence the surrounding interstellar medium, potentially triggering the formation of new stars and planets. In this sense, Betelgeuse's death is not an end but a beginning, a cosmic renewal that will shape the galaxy for eons to come. Betelgeuse's demise is a reminder of the impermanence of even the most brilliant objects in the universe. Stars, like all things, have a beginning and an end. Yet, in their death, they give rise to new possibilities. The elements forged in Betelgeuse's supernova will scatter across the cosmos, becoming the raw materials for future stars, planets, and perhaps even life. The James Webb Space Telescope has given us more than just a front-row seat to this cosmic drama. It has provided a window into our origins and a glimpse of our future. As our own sun approaches its eventual fate billions of years from now, the lessons learned from Betelgeuse will help us understand what lies ahead for our solar system. In the cold silence of space, 642 light-years from Earth, a star has ended its life with a brilliant final roar. Thanks to the James Webb Space Telescope, we have witnessed not just the death of Betelgeuse, but the birth of new knowledge. We have seen the signs of collapse, the detonation of a supernova, and the creation of the elements that make life possible. This is not just a scientific milestone. It is a moment of revelation, a chance to see our place in the universe with new clarity. As we reflect on Betelgeuse's final act, we are left with a sense of awe and curiosity. What other secrets is the universe ready to reveal? And are we prepared to witness them? The explosion of Betelgeuse is not the end of the story. It is the beginning of a new chapter in our exploration of the cosmos. Through the lens of JWST, we are decoding the chemical script of the universe, tracing the cycle of matter from the hearts of stars to the atoms within us. Betelgeuse's legacy will endure, not as a fading light in Orion, but as a beacon of discovery, illuminating the mysteries of the universe for generations to come.